All right, here's lesson 3, using logarithms to solve exponential equations. So this method involves taking the common logarithm of each side and using the laws of logarithms to solve the equation. So the first one, we're going to solve 2 to the x equals 5. So the first method we're going to do is to take the logarithm of either side. So log, like that. Now, because we're taking the log of either side, we can then bring down the exponent. And we can make this x log of 2 is equal to log of 5. And then solving algebraically, we get x is equal to log 5 over log 2. And you can actually evaluate that on your calculator. The method 2 is to convert to logarithmic form. So again, we start with 2x is equal to 5. Now the base of your exponent becomes the base of your logarithm. And your exponent becomes what it equals. So you have these two methods. Now, in both cases, we're ending up with what x equals. Some calculators will only calculate logarithms of base 10. However, if you evaluate any logarithm with base of b, it could be any base, using the change of base formula found on your formula sheet. So what this is saying is if you have log base b of c, you can take the logarithm of the argument, so log of c, and divide it by log a of b. So let's do a couple examples here. So log base 5 of 50, that is equal to log 50 divided by log 5. And on your calculators, you can actually type this in, log 50 and log 5. And log 50 divided by log 5. That equals 2.43. Okay. The next one, we can do log of 5/8 divided by log 2. And this will equal 0.67, negative 0.67. And the last one, we can take log of 1,000 and divide that by log 3. This is called the change of base. And this will actually evaluate to 6.29. And what this actually is meaning is if you take 3 and raise it to the exponent 6.29, that will equal 1,000. Now it actually won't because we're using a rounded value, but if you use the exact value, you'll get 1,000. So let's solve for the value of x. So we're going to change this to a logarithmic. So log base 3 of 10 is equal to x. So x is equal to log 10 divided by log 3, and x is equal to 2.10. Here we get x is equal to log base 7 of 3. So x is equal to log 3 divided by log 7. Type that into your calculator, log 3 divided by log 7, and you're going to get 0.56. And the last one, we're going to get x is equal to log base 4 of 27. So that is log 27 over 4. And that works out to 2.38. We can get a little bit more complicated, and so we might have to do a little bit of algebra or cleaning up equations before we actually take the logarithm of either side. So in this case, divide by 5 first, and you get 7 is equal to 3 to the x. That means x is equal to log base 3 of 7. And using our change of base, we get x is equal to log 7 divided by log 3. So x is approximately 1.8 if you evaluate that on your calculator. Again, you can type in log 7. Remember to close your brackets, divided by log 3. Hit enter, and you get 1.77, which rounds to 1.8. Okay. Again, we're going to kind of clean this up. So start by dividing by 500. So we get 2 is equal to 1.08 to the x. So x is equal to log base 1.08 of 2. And using our change of base, that equals log 2 divided by log 1.08. So x is going to equal 9.0. One more, you can divide by 100 on either side, and we'll get 45 over 100 will reduce. I'll do that in another step here, actually. Okay, 45 over 100 reduces to 9/20ths. And then you can change it to log. So log base half of 9/20ths is equal to log of 9/20ths divided by log of 1/2, which equals negative 2.2. That's a rounded value. Solve each equation, round to the nearest hundredth. So let's do it. So x plus 1 is equal to log base 5 of 24. So x is equal to log 24 divided by log 5 minus 1. That minus 1 comes from subtracting 1 from either side. Evaluate the first part on your calculator and then hit minus 1. And you're going to get 0.97. It's important that you're trying this step on your calculator. So pause the video, try it, and make sure your answer is lining up correctly. All right, so here we're going to get 2x minus 5 is equal to log, and this becomes your base. So log 2 of 3. And then again, cleaning up the algebra a little bit, we get log 3 divided by log 2. And then if I add 5 to either side, you get plus 5. Now here's an important thing. Make sure when you're evaluating this, do it in stages. So do this, add 5, and then divide the whole thing by 2. Okay? Otherwise, you're not going to get the correct answer. So in this case, you're going to get 3.29. All right, so again, add 35, just clean it up a little bit. 1/3 x is equal to 40. So we get x is equal to log base 130 of 40. So x is equal to log 40 divided by log 1/30th. So x in this case equals negative 3.36 as a rounded value. And our last one, clean it up a little bit, so divide by 3 to start. So you get 2 to the x minus 1 is equal to 8. That means we get x minus 1 is equal to log base 2 of 8. And x is equal to log 8 divided by log 2 plus 1. That plus 1 is coming from adding 1 to make 0 there. And if you evaluate this, you actually get 4, exactly. All right, lead-210 is a radioactive nuclide. If 8 grams of it decays to 6.75 in 5 years. So we need to come up with all these values. All right, so our initial value is 8 grams. Okay, our final value is 6.75. We're doing half-life, so our b value is half. Our time is 5 years, and our p-value, or how long it takes, is x. So setting up this equation, we get 6.75 is equal to 8 times 1/2 5 over x. So let's clean this up. Here, divide by 8, and you get 6.75 over 8 is equal to 0.5 to the 5x. All right, now let's take the log of either side. So 5 over x is equal to log base 0.5, or base half, of 6.75 divided by 8. All right, now you could solve these graphically if we just want to calculate it. Rearranging, you're going to get x is equal to 5 divided by this whole thing. So log base half of 6.75 divided by 8. So what that looks like on a calculator is going to be log 6.75 divided by 8, close your brackets, divided by log 0.5. That's what that whole shebang equals. And then we got to go 5 divided by that answer. And in this case, you get 20.39. So therefore, it will take 20.4 years. Or the half-life is 20.4 years, I should say. Okay, one more. We get this formula given to us. What is the investment in dollars, or y is the investment in dollars, and x is the number of years since the deposit was made. Determine how long to the nearest year that it will take the investment to be worth at least $800. So that is our y value. So we get 800 is equal to 500, 1.024 to the 2x. So clean it up a little bit. Divide by 500. 800 over 500 actually simplifies to 1.6. And we get this. Changing it to logarithmic form, we're going to get 2x is equal to log base 1.024 of 1.6. And 2x is equal to log 1.6 divided by log 1.024. That's the change of base. Okay. And then finally, we're going to divide each side by 2. So x equals log 1.6 divided by log 1.024. Hit enter and then hit divide by 2. So x is equal to 9.9. So therefore, it will take 10 years.